So as you can see, the recording is in progress. So if you do not want to be visualized in the later stage, you don't have to turn on your camera, but if you want to be, please, when I give you the sign, turn on the camera. So without further ado, let me just introduce our first speaker of the day, who will give the opening speech. Frode Solberg, the ambassador of Royal Norwegian Embassy to Korea, is with us, but unfortunately he cannot make it in person due to the urgent matter. So he sends his best regards to the team, and then he will send his message via recordings.
Dear friends, it's a privilege for me to welcome you all to today's webinar on autonomous shipping. This is an important topic, and I'm happy to see that well over 100 participants have registered for this event. Under normal circumstances, this would have been a physical event and a great opportunity for networking, but we hope that will be possible again quite soon. As many of you know, this is a topic that Norway has had on the agenda for many years. And I would like to thank you for once again being here, not least my good friend, President Buki Kim from KRISO, all panelists, participants, and my own team for organizing this event. Our global village is facing challenges, and as was clearly underlined in Glasgow over the past couple of weeks at COP26, we need to change. We need to change fast. The shipping industry will have to take its responsibility and do its part. And my impression is that the challenge is taken seriously, both by governments, ship owners, shipyards, the whole industry. But the solutions for the future are still not there. Norway and the Republic of Korea are both leading maritime nations. We have for decades, and perhaps I could say centuries, been spearheading maritime development. Today we are industry leaders in innovation, digitalization, and through cooperation, we are among those who drive the shipping industry forward. And let me add, Norway is an ocean economy. The history of Norway is a story about the oceans. More than two-thirds of our export revenues come from coastal and ocean-based activities, that being fisheries, aquaculture, shipping, or energy production. That is why our government, my government's ambition is to take a leading role internationally to secure a future where our oceans can provide more of the resources that the world needs, and at the same time as sustainability is secured. Making greater use of modern energy in shipping, including hydrogen, is part of the answer. In addition, an important reason for the entire industry is now collaborating on developing green and autonomous solutions, and that is the acknowledgement. Ultimately, there is no alternative. I believe the Republic of Korea and Norway will have great benefits of working together to enhance our efforts to achieve a green, a sustainable maritime sector through political leadership, through innovation, and even greater cooperation. And let me repeat what I've said before. With a combined maritime history of the Republic of Korea and Norway, with our expertise, our insight, our knowledge, if we can solve the future challenges together, who else can? In short, we have an excellent platform cooperation where we will find the solutions that the industry needs. I look forward to a continued close dialogue on these topics, and I wish you a very successful session and a very successful webinar today. Thank you very much for participating. 감사합니다.
Thank you very much, Ambassador. It was a great recording. Okay, without further ado, shall we go to our next speaker, who is going to be Buki Kim, the president of KRISO, who will give the welcome address. President Buki Kim, are you with us? We can't hear you.
Yes, I'm ready.
Yes, great. The floor is yours.
Yes. Good morning in Norway and good afternoon in Korea. Hi, everybody. My name is Buki Kim. I am basically responsible for managing Korea Research Institute of Ships and Ocean Engineering, KRISO. Today, we KRISO are very honored to be a co-organizer of this Korea-Norway Autonomous Shipping Online Workshop with the Royal Norwegian Embassy in Seoul. and Innovation Norway. As a president of KRISO, I am also honored to welcome you to this essential and precious workshop. First of all, I'd like to express my sincere gratitude to Mr. Brody Solberg, a Norwegian ambassador to the Republic of Korea, and all the participating experts today, including speakers and discussion panelists. Appreciate you technical experts made this workshop possible. As we are well aware, mass technology is currently opening up a new era of shipbuilding and maritime shipping. In today's workshop, I understand mass technology development status in Norway and Korea will be shared, and future further cooperation between two countries will be addressed during the workshop hours. Earlier, I was informed there will be time to exchange opinions among the participants regarding the development of mass sea trial, onshore control center operation, and establishing relevant international standards. I hope attending experts today from both countries can share the precious experiences, achievements, initiatives, and innovation efforts. At present, the fourth industrial revolution is giving us a fundamental change in the way of our living, work, and relating one another by constructing super intelligence and hyperconnectivity through digital technologies. By utilizing and implementing these technologies, the maritime industry will be much safer and much more sustainable. To realize mass technologies, therefore, it is essential to integrate digital technologies such as AI, big data, cloud, and etc. The realization may not be easy, but could be a long way to achieve. However, if we can tackle the challenge and make efforts together through our collaborations, I believe we can overcome such challenges and difficulties. KRISO stands ready to collaborate to develop the relevant mass technologies to lead the global maritime industry together. I'm pretty sure that today's workshop will be a great opportunity to share the best practices and boost up the cooperation between Norway and Korea. More than ever, I think the important keywords these days are collaboration and cooperation. In that sense, let's fully utilize our resources and expertise together to accelerate technology innovation in mass. I believe we can lead for changing the paradigm of shipbuilding and the shipping sectors in the forthcoming years. I wish you have a fruitful discussions and friendships as we all hope for successful workshop achieving next generation ship technology and safer marine transportation environment. Thank you all for your great support and participation to this workshop. Thank you so much.
Thank you very much, President Boogie Kim. Just by hearing what you're saying, I think our strong relationship between the two nations will be even stronger in the near future. Thanks very much once again.
Thank you.
Okay. Up next, since we have enough people, why don't we have a moment of photo time? So if, may I ask, everyone to sort of turn on their camera for just 2-3 minutes, if that's okay. We will do a couple of screenshots from many different people. So we love to see your beautiful faces. So please, don't be shy. We will not use it somewhere else, then we will share it too. Okay, great. Once again, smile. Once again, smile. And I guess we're done. I think everyone has what they needed, I think. I'm pretty sure. Okay, great. Thank you very much for your cooperation, and I really appreciate it. Why don't we go to our next speaker, Next speaker, our next speaker is Alexandra Vizak-Hogstad from Research Council, and she's going to talk about schemes for support of international cooperation. Alexandra?
I'm sorry, Insu Spark. The
Yep.
next speaker will be Dr. Onor Losset from Sintep Ocean.
I see. Then Onolf will talk about overall mass activities in Norway. Onolf? Yes, the floor is yours.
Thank you. Let's see if I can share my screen. Share. Okay. Thank you for the opportunity to talk at this event. And I will try to give an overview of what we are doing in Norway, why we are doing it, and also some thoughts on cooperation. So first, why are we doing this in Norway? And of course, sustainability is one of the driving factors, in my opinion, and particularly the drive towards greening of shipping, removing greenhouse gases from emissions. And the problem we are facing, of course, is, at least for the time being, the proposed energy carriers are quite expensive compared to heavy fuel oil. And they are also very high in volume compared to fuel oil, as well as being corrosive, explosive, very cold, or even poisonous. So we have some major changes, I would say, in finding a good energy carrier for tomorrow's shipping. And this, I think, could easily lead to new ship types, new supply chains, new business models, and certainly more automation and digitalization in the shipping sector. And this is also where autonomy comes in. So, we are looking at smaller ships. I'll come back to that. And if you have smaller ships, you have to control the crew cost and so on and so forth. And in any case, I think these changes may very well be disruptive to shipping as we know it. Most of the business models in shipping is close to 200 years old, so it may also be time to have a closer look at how we do this. Also in Norway, which is, I'm not sure if this is the same problem in Korea, but reduction in road traffic is also an important objective here. And that has to do with queues on the roads, space use. We are starting to use electric trucks, but that won't help much on some of the dust, particulate matter emissions. Noise is a very important factor here. They claim that more people are killed by indirectly killed by road noise, leading to heart diseases, than by road accidents in Norway. Winter road problems is quite common in Norway, particularly on the more remote roads. And the infrastructure cost is tremendous. We are using more than 20 times as much on road infrastructure in Norway than we are using on sea infrastructure, even though if you look at cargo transport in Norway, inland, in ton kilometers, is about the same on sea as on road. So there is a need to have a very close look at how we do this. Unfortunately, we see that ship transport tends to lose compared to trucks. And some of the reasons is basically that we are stuck with the fixed terminals that the ports represent. So one of the things we are looking at is more and smaller ships. That allows us to differentiate the speeds. We can increase frequencies, of course. We can give different priority to different cargoes and so on and so forth. But to have more and smaller ships, we also need to take care that the crew cost is not overpowering kind of the benefits we see in the new transport system. And that's where various types of automation and autonomy comes in. We essentially want uncrewed ships. And uncrewed ships is also important in terms of reducing power. The accommodation section is typically using a couple of 100 kilowatts, which is quite significant for small ships. And for small ships, the space that you can use for cargo is also significant. So we can also increase cargo capacity by making uncrewed ships. This doesn't necessarily mean that the ship is fully autonomous, which I don't think will happen, at least not in the near future. We are also talking about remote control here, of course. It's also very interesting for us in Norway. We have 32 designated main ports in Norway, but there are actually 659 ISPS ports. That's ports which allows international ships to call, and 1,300 terminals. Just in the Trondheim region, where you can see one designated ports, we have close to 40 smaller ports that we can use. And we also have a lot of fishing ports. So we really have a very big infrastructure for doing new types of transport systems on sea that we are not yet utilizing. But this requires more automation, both of ships and cargo handling. And this is one example we are looking at. Today, the ships are going into the Trondheim Fjord to Orkanger, and that takes about 5 hours back and forth from the main fairway. If we can have a shuttle service, for instance, based on concepts from Europe, waterways, CFAR, and others, we could save 5 hours on just this call on the main coastal fairway, and also increase the system by calling on smaller ports along the fjord. Another point which is important in Norway is improved passenger transport. This is probably not so relevant for Korea, but we have a lot of highway ferries, and one of the things we are looking at there is increasing the frequency and flexibility with smaller and more frequent departures. We also have a lot of islands with relatively small populations. These are two examples from Trondheim, one with 600 persons on the island and one with 20 persons on the island, which are served by ferries. And the point here is to increase the service to 24/7 with more departures, justified or on-demand departures and stuff like that. And autonomy, again, is a very interesting, or not autonomy, but uncrewed operation or low crewed operation, which again requires autonomy. Is a very important means to achieve this. And of course also urban waterways, which is very much underutilized as passenger transport needs in Norway and other places. We have quite a lot of these small ferries, but there is a big potential for increasing this. I'll come back to that. The status is that we are already automating many of the highway ferries with automatic crossing and automatic berthing, and this is going to be developed further. But this is not really autonomy, it's a kind of advanced autopilots. As you may know, we have two small short sea ship systems on order, and these will both be put into operation first quarter next year. Yarabikland and Asko ferries. There are two of the Asko ferries and one of Yarabikland. And these will start commercial operations early next year, and the plan is to make them uncrewed from 2024, gradually decreasing the crew and using remote control to assist. We have several new companies being established to serve these new markets. Seabus and Hike is particularly targeting the passenger market with the smaller automated ferries. Masterly is the company that is going to operate the remote control centers and assist ship owners or ship operators in managing these automated and remote control ships. We also have activities on surveys with the Armada Ocean Infinity project, and also a lot of different kind of activities around this, which is not really mass, but unmanned surface vessels, autonomous underwater vessels, cargo handling, and so on and so forth. These are just a few examples from the membership of NFAS. There are two large new projects running, Aegis and Autoship, which is partly working on cargo handling, Aegis, and which is actually going to demonstrate inland and deep sea shipping in Autoship in about 1 year, 1.5 years. We have also recently established a new Center for Research-Driven Innovation here in Trondheim, operated by the university, NTNU, with a relatively good budget and high activity on the academic and research side. And of course, the Norwegian Forum for Autonomous Ships is still in operation, which I manage. And as you can see, Trondheim is certainly a kind of international powerhouse here, where a lot of these Norwegian activities are concentrated. Not the least the new Ocean Space Center, which is going to invest about $600 million in new laboratories for the SINTEF and NTNU. And finally, I thought I should say a few words about the international cooperation. I mean, this autonomous ships is obviously of big interest, and there's a strong international competition, but you also need to cooperate. And one reason for this is the legal and regulatory situation. It's very unclear, and we still need to work together to find good regulations, whether these are regional or international or based on various guidelines. And also, the new regulations, when they arrive, they are expected to be goal and risk-based, and that will be quite expensive to approve ships through such types of regulations. So I think also there is a need to look at the cooperation to find practical solutions to this, and also more technical performance standards where possible. Autonomous ships are not ships, they are systems, and there's a lot of different interfaces that has to be handled. Communication between the ship and remote control. If that is not standardized, the ship owner will be married with the remote control center. So there's, I think, a big need here to look at more harmonized interfaces and standardized. And the same with the interfaces to port infrastructure, both cargo handling, mooring, charging, and so on. There's a lot of problems, I would say, or challenges with the development of MAS, system integration. How can we do that cheaper? Interfaces to RCC, I've mentioned that, in port infrastructure interfaces, rules and regulations, as I mentioned, but also standards for training of crew and acceptance criteria, safety analysis, and things like that. And the point is that standards can significantly reduce cost and increase innovation. And we are a very small segment. There are about 100,000 ships in the world compared to, for instance, 6 billion smartphones with 2 operating systems. And we cannot rely on a kind of evolution of standards from the market itself. I think we really have to have a targeted cooperation to develop these standards. And once we have the standards, we can start to look at the new innovative solutions that can really make the industry earn money. So to conclude, autonomous ships still have a very high interest in Norway, both from academia, industry, and governments. Development and sustainability goals will be an important driver, and I think we can easily see some major disruptions in the business cases, business processes, and this is, I think, very interesting for the concept of automated unmanned ships. And in spite of the competition that we already see, there is a very important need for international cooperation. So thank you for your attention.
Thank you very much, Arnold. It was great, and then you addresses quite importance of the international cooperation with the standard, so that we will try to not make MAS not that expensive. Yes, great. Thanks very much. And then a small apology for the orders or the queues, because supposedly Chin Kim was the first, but you know, it's Norwegian Innovation Norway, so give a little small favoritism to the Norwegian speaker first. An apology for that. Next up, we have Chin Kim, head of CAS from KRISO, and then he will talk about progress on CAS project and validation plan. Chin Kim, are you with us?
Yeah, thank you, Chairman. Yeah,
Thank you.
It doesn't really matter to the order. It's okay. Today, I will introduce the Korean National R&D project, the KAS. So I will introduce the progress on KAS project and our validation plan. This is a brief outline of the Korea Autonomous Surface Ship project. It is funded by Korean government and also participating private companies. The project period is 6 years. It started from last year. The goals are development of key technologies of autonomous ships and making a basement for commercialization of the developed systems through phase test and validation. We defined 4 core technologies, such as intelligent navigation system, and engine and machinery automation system, and sea testbed and validation technology, and finally, the operational technology and standardizations. We are targeting IMO-defined autonomy level 3 for ocean voyage and level 2 for coastal operation with a real commercial ship. Let me show the members of the KAS consortium. KRISO and Korean Register take charge in project management. Korean shipbuilding companies and shipping companies and small IT ventures and many Korean marine equipment companies and institutes and also universities are participating in this project. In particular, Lloyd Register in UK also joined this project for the development of validation procedures. This chart shows the composition and development period of sub-project for each core technologies. The project consists of 4 core technologies and 13 sub-projects. 8 sub-projects had started last year and others started this year. So all of the projects are ongoing now. First core technology is the autonomous navigation system, which develops the integrated platform and digital bridge for navigation and engine room control, and also include navigation awareness and collision avoidance system, and finally intelligent navigation system can make a navigation plan and collision avoidance support system considering ocean and coastal environment. The second core technology is the autonomous engine system, which enables IMO level 3 autonomous degree in all areas of engine and machineries operation, including port, which develops the condition monitoring and intelligent fault diagnosis system, and a system that provides an integrated simulation of all energy systems on ship, which can check compliance with environmental regulations. The core technology 3 established the infrastructure and developed the related technologies to verify the performance of advanced sensors and automated or intelligent systems. It consists of 5 sub-projects, which includes shore base control center for autonomous ship and 24-meter class small test ship, and develops validation procedures for mass operation, and also develops remote control system on shore side, and also digital communication system for ship to shore and also ship to ship. And finally, cybersecurity systems are also included in these core technologies. Fourth core technology is autonomous ship operation techniques in a viewpoint of shipping companies. And finally, standardization of mass technologies. It includes the instant response system in case of fire or flooding. And we also developed the port-linked decision support system and each platform. And we'll suggest international standardization for mass technology, such as detailed autonomous degree and also testing and validation procedures. For the purpose of validation, we'll build a small test ship to validate or develop digital system. We also build a CAS shore control center. It will be operated from next year. Finally, the autonomous technologies are equipped on a real commercial ship and validated with reliable test procedures in final 2 years. In order to manage and also help the development of 4 core technologies and 13 sub-projects, CAS project office is organized. The office consists of project head and vice head and staffs. The project head and vice head manages all sub-projects and make the links between the sub-projects. We'll operate civilian commission for important decision-making and advice. We are considering 3-phased validation steps, including simulation and small test ship and the actual commercial ship test. In terms of validation for mass digital system, no appropriate procedures exist so far in the world. For the commercialization of mass, I think there could be 2 different types of challenges. The one is about how effectively to integrate all functions and verify them under some appropriate test bed and infrastructure. And the other could be about how to get an accreditation or approval for commercial operation in safety and security point at least. I think that is the reason why validation of mass digital system is very important. Mass control center will be constructed at Gonul district of Ulsan City. Ulsan City is located at southeastern shore side in Korean Peninsula. Nearby, there are Hyundai Heavy Industry and also Hyundai Mipo Shipbuilding Yard. The right bottom photo shows a bird's eye view of mass control center, which has a radar dome on the top. The right above photo shows a range of radar covering area, and a small 24-meter test ship will be operated in green-colored region. The design of mass control center was started at the end of last year. The groundbreaking ceremony was last month this year. The mass control center will be ready for operation in the middle of next year. The first step of validation is simulation-based test bed for autonomous ship. We named it as TAS. Real situation in the right side photo will be simulated in STAS system. We'll simulate a test ship and also with virtual other ships, virtual obstacles under the virtual ocean environment. The key technology for STAS would be VDGS, which is Virtual Data Generation System, will be developed, including marine obstacles, marine weather environment, and scenario for testing. The STAS system will be equipped at Mass Control Center. The next step is testing a real ship at real ocean environment. The real ship and ocean environment replace the virtual condition of simulation-based system. Two real ships, such as a 24-meter class small test ship and a commercial ship provided by participating shipping company, will be tested in this project. We'll operate the test in both or mixed generated virtual obstacles and also real obstacles. Mass Control Center will have a digital twin bridge and big data platform and communicate with the shipboard digital bridge. We'll develop the test scenarios and procedures to validate the intelligent navigation system and also engine automation system, including cybersecurity. We'll build a small test ship. The ship main particulars are shown here. It is 24-meter long and gross tonnage is about 40. Test ship will be launched at the end of this year or early next year. Situation awareness system with sensors and digital bridge with autonomous navigation system will be equipped on this test ship. This slide shows the concept of system interface and data flow structure between an autonomous ship platform and mass control center. All data in a ship will be collected at the digital bridge, and also show data will be collected at the digital twin bridge of mass control center. Ship-to-shore communication is performed between digital bridge and digital twin bridge. We are adopting ISO 19847 and 19848 for data standards. The Korean private companies will have R&D outputs such as engine automation, situation awareness, intelligent navigation, communication system, and cybersecurity, and etc. In terms of validation for mass digital systems, as I say, no appropriate procedures exist so far. The commercial operation of mass in the future will strongly depend on how to get an accreditation or approval in safety and security points. The KRISO project will develop the procedures for checking and validating all digital systems of mass. We would like to cooperate with all other nations in order to make the international standard of mass verification, validation, and accreditation. The KRISO project will help the participating private companies to get the track record to make their own business model themselves. This slide shows the methodology for validation of each digital systems on board. The KRISO project cooperates with the Lloyd Register for this digital twin ready validation. The V model, we call it, is adapted and will be followed from system goal to final validation. Now we are on the stage of component requirement and verification stage. At first, STAS for situational awareness, collision avoidance, and engine monitoring are now being evaluated through Lloyd Register digital compliance and risk assessment on this V model. And STAS and VDGS will be approved for digital twin ready or approved in terms of both V model design approach and Lloyd Register digital compliance frameworks. Through this digital twin system, KAS project will validate each autonomous function reliably before onboarding. However, even though each digital systems are validated, we all still have a big challenge. It is how to approve or give a certification to a ship to sail in autonomous mode. Let's think about our usual life in ground. We have to get a driver license to drive a car. However, we don't have any globally approved way for ocean-going commercial ships in autonomous mode. So all the ship class have a definition of autonomy level, more detailed than IMO defined level, but there are no appropriate procedures to evaluate it. So now it is the time to discuss how to get an accreditation or approval for autonomous ships. We might need more detailed autonomous degree to evaluate a mass. Now I will summarize my speech. So Korean National R&D project for mass is launched in 2020. Sea testbed, including a small test ship and a commercial ship, will be prepared for validation. Validation utilizes both the simulation-based and the real sea trial. And also all the data structure will be based on ISO standards so that KAS project could be contributed to future ISO revision, especially for autonomous navigation. Now it is the time to discuss how to get an accreditation or approval for autonomous ship together. Thank you. Thank you for attention.
Thank you, Dr. Jin Kim. It was a wonderful presentation. And then some comments about accreditation, because there are a couple of other matters from, especially from the insurance company, that they don't want to insure the autonomous cargo ships. So that was one of the examples that I know from the e-mobility, autonomous cars. And we'd be glad to be invited for the test ships launching. We'd be happy to be the witness. Thank you very much once again. And our next speaker is Alexandra Wizak Hugstad from Research Council of Norway, and she will talk about schemes for support of international cooperation. Are you there, Alexandra?
Yes, hello, can you hear me?
Yes, nice and clear.
And am I sharing my screen so that you can see it?
Yes.
Yes, perfect. So good afternoon, and thank you very much for inviting both me and my colleague Kjell Rang to this workshop. My name is Alexandra Haugstad, and I work with international cooperation at the Research Council of Norway. So today I hope to provide you with information about opportunities for developing new cooperation between the Republic of Korea and Norway. I will start with a few words about our organization so that you can understand from what point I'm speaking, and then explain how funding for maritime research is organized in our system, and then move on to funding schemes for international cooperation, as well as RCN's cooperation with the Republic of Korea. So let's see if I can move this in. So just briefly, the Research Council is kind of an organization covering all subjects and disciplines in Norway and all thematic areas, and supporting research activities, and as well as innovation and commercialization. We handle about 1/3 of the public investments in research, development, and innovation. And you can see that funding coming through our system is coming both from the Ministry of Education and Research, but also from other ministries with other responsibilities. And going to both the higher education sector, the research performing organizations, and as well industry. So this is what happens kind of each year at the Research Council. We invest around 1 billion euros annually into different types of schemes. You will find maritime research supported through all those different types of measures. One example has already been mentioned, the Autoship Center for Research-Based Innovation, that would be funded from one of our Center of Excellence schemes, as well as the AMAS Center for Autonomous Marine Operations and Systems, both hosted by the Norwegian University of Science and Technology in Trondheim. And if you're curious about those kind of types of projects that we're funding, we have something we call the Project Bank. So it's a portal where you can go in, you can type a keyword like autonomous shipping and see projects that have been funded by RCN in the past, and also ongoing projects, which might be even more interesting. So how funding for maritime research has been organized within our system. We used to have a program, dedicated program for maritime research since 2002. And you can see some kind of basic facts about it. Its program plan was last revised in 2017. And you can see how kind of what were the kind of strategy background for it. And the thematic, this is an important point, the main thematic priorities in this program, which included then autonomous and remote control vessels. And you will also see greener maritime activities also mentioned as an important point. So current kind of Research Council of Norway quite recently reorganized the way we structure our calls and our funding, so that if you go to our website today, you will no longer find the MARO program. But kind of that does not change as much as it might seem. The funding and the priorities from the MARO program are still part of our system, but they're now placed in a different, they're now placed in a portfolio for oceans. So if you want to update yourself on the policies and this, the main priorities for research and development in the future, kind of now you should go to the portfolios rather than the programs. So this has changed, but the funding streams and the funding level, the funding priorities have not been affected by this. So now moving to the schemes that we have and the strategies for international cooperation, which was already mentioned by Arnulf as kind of what will be important to you on both sides now. There is a strategy for cooperation formulated by the Norwegian government for cooperation in research and higher education with countries outside Europe. And since kind of this spring, 2021, the Republic of Korea has been included in the list of priority countries. So this changes quite a lot from our point of view. We now have kind of a very clear green light and incentive to promote cooperation with South Korea. So there is a government strategy. Prior to this government strategy, RCN also developed a roadmap for cooperation on research and higher education in 2019, describing mapping the potential areas for cooperation and the reasons for why South Korea should be included among priority countries. So both these documents are available in English. If you're curious about them, I can provide links to where you can find them on the web. So among the promising fields for cooperation that were identified in the roadmap for cooperation prepared by RC in 2019, these were the fields selected, and you will find digital technologies here, which would be very relevant for your field. And then I have to say, this is what was identified as promising fields for cooperation. It's not a closed list. It's not something that we think will stay fixed forever. So we're open to new developments and also to input from researchers, industry, and other stakeholders who have ideas for our areas for cooperation, and we will listen to you. So we very much invite you to share with us your thoughts on what should be priorities and where is the potential for future cooperation. So for example, at a recent webinar we organized on a Norwegian Korean cooperation, I conducted just a short informal survey among the participants to ask where do they want, where from the Norwegian researchers' sides, where would they like to cooperate with South Korea? And this was a very narrow sample, so we're not going to overinterpret this. But what it did tell me that I think was interesting, there was a very wide range of topics and disciplines that were mentioned. You see green ships and maritime topics mentioned here as well. So I think there are a lot of possibilities. We might not see all the possibilities that are out there yet, and I'm very much interested to listen. We already have something to build on, a framework for cooperation between our organization and South Korean organizations. We have a manifold cooperation agreement with the Korea Institute of Energy Technology Evaluation and Planning, which allows us to open funding streams on both sides to researchers from the other country. We have an MOU with the National Research Foundation of Korea, which is also a good platform for cooperation. And we take part in different platforms with several countries involved, which allow us to meet South Korean partners. So also important to mention that HIAT and RCN are both Eureka members and have also a letter of intent signed, so which means that Norwegian and Korean partners can meet in Eureka projects. Now I can mention this later as well. So we are also following the situation and trying to see what is happening. And one of the indicators we follow is joint publications involving authors from both countries, which is one way of trying to measure the level of cooperation and the trends of cooperation. And what we see with number of articles and reviews and proceedings, papers with Norway and South Korea co-publicating between 2016-2020, just the most recent developments, we see a continuous and upward trend, most pronounced in physical sciences, but we also see for engineering technology, the trend is upward. So we're very much encouraged by this trend and want to see it continued. Now moving over to what is more practical, where are funding schemes and possibilities of developing joint projects and corporations, where is funding for international cooperation? So at the Research Council of Norway, our main policy is now that the main calls for research projects are now open to international partners as well. So it means that the Norwegian applicant can, when setting up a consortium for his project, his or her project, can invite also international partners and can also dedicate part of the funding, part of the budget to that international partner. This is so far something that we can make work for research organizations. With companies, that is kind of because of competition rules is more difficult. So it's not impossible, we're told, but it's more tricky. But for research organizations, this is now in place. So just to let you know, this is from our point of view, the main way of supporting international cooperation from now on. We also have some dedicated schemes to international cooperation, and the most important is called INTPART, so abbreviation of International Partnerships in Excellent Education, Research and Innovation. This type of calls has existed for a longer time, but it was open to include South Korean partners since 2020. And we already have 2 projects supported with South Korean partners. And there is a new call opening quite soon. It's already published on our webpage. The call deadline will be mid-March 2022. And this is, I think, one call that you should consider if you're looking for opportunities for combining and connecting partners from Norway and Republic of Korea. The third kind of avenue for funding international cooperation is through multilateral cooperation. So Horizon Europe and the European programs are very central and very important to us. It's kind of the third part of the main policy of RCN is to support Norwegian researchers in kind of any way we can find to make it attractive and possible to take part in European projects, both Horizon Europe, Eureka, so Eurostars project, and also European partnerships. And such projects are often open to partners from outside Europe. And we really do hope that to see South Korea also in some way associated to the Horizon program. As far as I understand, this is not decided yet, but at least it means there is no negative decision, and we're hoping for some positive solutions on this. Throughout the Horizon 2020 period, program, we saw 12 projects supported that had partners from both Norway and South Korea together. And we saw that advanced materials and ICT was the topic of half of those projects. So we see a lot of cooperation on these topics. And also in from Eureka, there has been support to 5 Eurostars projects with Norwegian and Korean partners within the areas of technology and also a mix of technology and medicine. So we hope that you will also look at these funding opportunities in the future. And I'm coming to the end of my presentation. So from the Research Council of Norway, we're very proud to be part of Team Norway, which is a cooperation between Norwegian agencies abroad. So we're working closely with our colleagues at Innovation Norway and also at the embassy. And you're welcome to contact us and to Norwegian institutions and participants present. Do let me know if you want to be added to my list of mailing list for news on and interesting information about cooperation with South Korea, so that I can keep you informed. And lastly, if you want more detailed information about the different funding and call types, you can also check out the presentations from our last webinar, which you can find, where you will find more detailed information about the INTPART call, and also a presentation on a call called Utforsk, which is organized by the Directorate for Higher Education and Skills, are another partner institution, which is also has an open call coming up real soon. So this is all I wanted to say. Thank you for your attention. 감사합니다.
Tusen tak, Alexandra. It was really nice. Just one short request to Alexandra, if that's okay. I've been trying to look for the fund web pages. Do you think you can sort of have the cut and paste of the page to our chat window, if that's okay? Your recent calls for the R&D.
Yes, you mean kind of to the call for
The March one.
Yes, let's see, because I think I had made sure to include a. I'll check if I can manage to open.
Sure.
So let's see if I can check.
Oh, I think we just have to continue, but if you can
yeah, so
copy
maybe
and paste. Yeah. Yes, I can see the web page.
Yes, and so, but I can include the link in the chat.
Yes, please.
Maybe that's a good solution. Okay.
Yes, great. Thank you very much. Thank you very much. I think the research opportunities between two countries, not only from Norway, but there's also EU funding opportunities available through Eureka and Eurostar. So please do not hesitate to contact either Innovation Norway, us in Korea, or Alexandra from the Research Council in Norway. Next up, it's Son-Young Kim, the principal researcher from KRISO, and he will talk about the introduction of USV Argon 3 and recent test at Korean regulatory sandbox for USV. Are you here with us, Dr. Kim?
Okay, thank you. Do you hear me?
Yes.
Okay, then yes, I'll share my computer screen.
Yes, please.
Can you see my presentation file?
Not quite yet.
Not yet. Okay, just I'll try again. So.
Yeah, I see something is changing. Yes, now I can see.
Can you see? Okay.
Yes. Yes.
Okay, then I'll begin.
Yes, but it's not in the presentation mode, if that's okay.
Oh, yeah, okay. Okay.
Yes,
then
now I can see it. Yes.
Okay. Today, yes, I'd like to introduce the recent test which has been done with USB Argon 3 at the Korean regulatory sandbox. 그렇죠? 이렇게.
Yeah, I think you can continue.
Okay.
Yeah, it was fine. It was perfectly fine before.
Just a moment. Just a minute. I cannot share my screen. Okay, just.
No problem. Take your time.
Okay.
For your information, while you're waiting, Alexander has put up the website in our chat window. If you're interested in it, please go and have a look. Thanks very much.
이것은 왜 갑자기 멈췄지? 오케이. 오늘 지금 됐나? 취소. 파일 그대로. Okay, I'll continue.
Yes.
Yes, today my presentation will be followed like this. At first, I will introduce very briefly the USB Aragon 3, which is the heroine of our test. And then next, I will also briefly introduce Korean regulatory sandbox for USB, which make it possible for us to carry out this test. And yes, I will introduce very briefly about our test results. Actually, yes, this test was finished last week, so the test results are very quite recent results. And finally, I'll conclude. This Aragon 3 was developed sponsored by Korean Ministry of Oceans and Fisheries, which is based on the R&D project. Almost this project was carried out for 8 years, and KRISO was the leading organization. During this 8 years project, we have constructed a series of USB, the Aragon 1, 2, 3, and which was constructed 2013, 2016, and 2018. Naturally, Aragon 3 was the most high version of the USB. Then the main feature of Aragon 3, the platform is consists of a planning oil with water jet, and the maximum speed is 45 knots, and which can be operable up to sea state 4. And we have a triple communication system for the robust communications, and we have got autonomous navigation system, which includes the automatic path planning and following, and the automatic obstacle detection and the tracking by sensors fusion, and automatic collision avoidance system. We have also some mission equipment systems for the maritime surveillance and ocean survey, which includes the UIL camera and the water cannon and the radar and the multi-beam sonar, HDP, CTD for the ocean survey. And we have also launch and recovery system for the use on board the system. So we use heaving line launcher for USB, and we also use the crane on board. This slide shows the example of the automatic obstacle detection and tracking. As you know, yes, this obstacle detection and tracking system is very, very important, and it is very difficult to realize. So we have used various sensors, including our radar, LiDAR, camera, and IR camera. Each sensor has some advantages and disadvantages. So we have to use some sensor fusion technologies to use their the advantages and disadvantages. This is the example of the automatic collision avoidance test. So this the Aragon 3 is carrying out the collision avoidance test seriously. At first, the Aragon 3 meet two ships are coming from the left hand, right hand. So got the Aragon 3 are doing collision avoidance test by keeping the colleague rules. And next, the copy another ship is following from the you can see the ship coming ahead, and you can see that the Aragon 3 detected the ship and find the proper way to collision avoidance. I'll explain about Korean regulatory the sandbox. In Korea recently, the companies complain because it is very difficult to introduce new technologies and service due to high regulation in Korea. So they need to reduce the lead time of products or service based on new technologies. So the government established a regulatory the sandbox. The principle is to make it easier and faster for new technology product and service to launch in market. Korean government adopted this system in early 2009. The main the idea is there are three options. As if some company have some product or a service which is based on the innovative technologies, they can ask the government if their product is there is any regulations for their product. Then the government should answer for their ask and check if there is any regulations or not. So then if there is some if there is good regulations, then the company can do market launching. But if there is any regulations, such as some ambiguous and unreasonable regulations, then the government check this the product or service is safety or not safety. So if the product or service is secure to got to be safe, then the government allow the temporary permissions. Then after they launch the market and the government revise and make up the relevant laws. And the secondly, if the product or service is not is uncertain for the safety, then they propose that some regulatory special case for demonstration is required. Then after this demonstration has been done, if the safety is proved, then they approve formally. And if the safety is not proven, then the market is, cannot be launched. There is another system regarding with the regulatory sandbox. The regulatory of the free special zone is operated by the province or cities, not by the company. So there are many regulation free zone, free special zone in Korea. And one of these regulation free zone is zone includes the including government vessels. So Gyeongnam, the Gyeongnam has applied for the unmanned ship regulation free special zones, and this special zone has been allowed from 2020 to 2023. The designated area is the Anjeong route and the Goje East route and Gyeongnam boat license test size. So in this test area, any participants can carry out some demonstration tests, and the government supported some R&D project, and they provide some infrastructure for USB test, and they are going to establish some law and regulation for USB. Now there are three main participants. One is CSWORD by the LIG next one. The one is the KRISO, and one is Hanwha. Then I'll explain the test results. The main objective of this test is to demonstrate the safe operation of USV Aragon 3 in Korean coastal areas. More concretely, we are going to demonstrate the remote and autonomous operation of USV Aragon 3 for longer than 2 hours and 40 kilometer navigation. We also want to get some USVC trial data, which will be required for making regulations of USV. So, although we have developed our USB for 8 years, still there are many issues to be solved for this test. At first, the Korean coastal topography has very complicated. So there are many islands and there are many mountains. So the communication system based on the LOS system is not be working in this kind of environment. And secondly, there are many fish farms and small buoys in the Korean coastal waters. So there is a high risk of being wrapped by rope and net. And thirdly, there are many small fishery ships, but this small ships has a very poor navigation equipment, and the captain is not also well-educated persons. And the next, we need to communicate with the traffic ships and VTS because although USV can be operated autonomously, but the traffic ships and the VTS want to know how our USV situation is. And finally, we need to prepare some the emergency response plan in case of the breakdown of USV. So I'll explain this, how we prepare such kind of issues. At first, to have some BLOS, beyond loss communication system, we have adopted LTE systems. With these systems, we have carried out performance tests like this graph. So we can find that in the all areas, the test performance was quite good, and we can get the communication speed. The communication speed is about 5 Mbps. And we also have installed the VHF communication on Aragon 3 to communicate with surrounding ships and the VTS. We have developed a relay system between Aragon 3 and the ground control center for GCS operator to talk and listen. Since this relay system is with LTE, GCS operator can communicate even in case that Aragon 3 is far away from ground control station. Okay, then I'll introduce Korean navigation service. Korean government developed a Korean e-navigation system for 5 years to enhance the maritime safety and began the innovation service from 2020. There are three main elements of innovation system. Firstly, LTE-M network has been constructed. This communication network reaches to about maximum 100 kilometers from land, and the minimum communication speed is about 10 megabps. Secondly, at maritime, the connective platform has been developed for ship to shore to ship data communication. And thirdly, ECS, which is a kind of navigation service terminal, has been provided official ships to use the navigation service on ships. ECS is a mandatory equipment for all Korean domestic ships, and they expect that 6,000 ships will equip ECS by 2021. So we have used this service to enhance the performance of Aragon 3. The service we have adapted for the Aragon 3 is as follows. First, we adopted the route planning service because this service use the boost updated GIS information. Secondly, we use the information of position and speed of ships which equipped with ECS. With this service, we can track very small fishing boat very accurately. Thirdly, we utilize MCP and the ECS system to share the navigation intention with the opposite ships during collision avoidance. This is the some slide shows the detection of the LiDAR. Detection range of LiDAR is not so long that LiDAR is less useful than radar for collision avoidance with ship. But since LiDAR provides three-dimensional data with very high resolution, LiDAR is very useful to detect and identify small obstacles and ships in close distance. This slide shows an example of detecting ships and buoys, and so we used LiDAR to detect buoys when USV were passing fishery farms. This slide shows a ground control station. So you can see the ground control station. This ground control station is inside of camping car, and the camping car is parked at the Gwangham port, and the USV Aragon is berthed at Gyeongnam boating license test site. We have carried out a long voyage plan test scenario. The long time operation test scenario is between Gwangham port to Anjeong route. So during this voyage, we put many events, include departure and passing through fishery farm, and collision avoidance, and ocean survey, and distress response, and arrival. I will pick up as some case for a rough demonstration of our test. This slide shows the total operation track. So all of the track are recorded in this slide. So we measured our total operation time is up to about 3 hours and 10 minutes, and the total traveling distance was 40 kilometers. So this was this long distance traveling and long time operation is one of our objective of this test. So we can say that we have completed our objectives. So this, okay, no. This slide shows some typical test environment. So most of control and monitorings are carried out by the ground control stations operators by seeing the cameras and all of the sensor data. And naturally, there is no person inside of this USB. This test scene shows the navigation. The USB is passing the fish farm. When Aragon 3 is passing fish farms, GCS operators monitor this kind of the electronic navigation chart and the camera and the LiDAR data carefully and check if there is any buoy on the course of Aragon 3. If they find any buoys on course, they change course just by simple manipulation of these waypoints. Here, the information of fish farm is displayed on this ENC, but we cannot trust these data because this fish farms data is repeated up to 100 meters. So, and as you can see, we cannot confirm small buoys with this camera. So we need to use a LiDAR system.
Sorry to interrupt, Dr. Kim, but could I ask you to finish the session within a minute or two?
Okay. I almost finished. This is a very interesting test. This slide shows the test of navigation intention during the collision avoidance test. So there are the situation is like this. There are 3 ships which might collide. So the ground control station's operator calls 2 ships, the Mansong and the Daeang, and discuss which way is to avoid the collision safely. So they agree on the changing directions, and they send their changing course. So you can see that each ship and the ground control station has this ECS system on the left-hand side. And here they can see the opposite ship will follow which courses. So we can doing collision avoidance very safely. Finally, yes, I'll show the automatic bolting system. So the well, you can see that at Aragon 3 bolts very efficiently. Yeah, but the video clip is very jammy. Okay. Anyway, yes, we have succeeded to unboxing. Okay, so I'll conclude my presentation with the following. We have carried out. We have a demonstration to the safe operation of USB Aragon 3 at the Gyeongnam USB regulation-free zone. During this test, we have found out that to operate USB for a wide application in Korean coastal area, following are required. First, beyond a loss communication system like LT or satellite is required. And we need a VHF system for communicating with traffic ships and the VTS. And so we needed to have some small VT detecting system to avoid small accidents. And finally, the Korean navigation system services are available to enhance the tracking performance of small fishing boats and to reduce the risk of collision by sharing navigation intention. So if some USB operate, the manufacturers thinking about the operation of USB in Korea to adapt the innovation system is will be very useful. Okay, thank you for your attention.
Thank you very much, Dr. Son Young Kim. Without further ado, should we go to our next speaker? Next speaker is Hyungju Kim from University of Southeastern Norway, and he's going to talk about cooperation for sea trial test and remote control center between Korea and Norway. Hyungju Kim, are you with us?
Yes, I'm here. And yeah, and Dr. Kim, can you stop your sharing screen because I cannot share my screen? Yes, thank you.
Okay, it's done.
Yeah,
그래서 어떻게 해야 되지? 이거. Okay, I did.
Yeah, thank you.
Sorry.
This is no problem. Yeah, and can you see my screen?
Yes, we can.
Yep, thank you. And then, first of all, thank you, KRISO and Norwegian Embassy and Innovation Norway for this workshop. It is an honor for me to present at this workshop today, and I hope this will be a good starting point of the collaboration between Norway and Korea in autonomous shipping. And I am Hyungju Kim, an associate professor at the University of Southeastern Norway. And today I will present one possible joint collaboration idea. As you can see here, the research and demonstration of intercontinental autonomous ship operation between Norway and Korea. So let me first start from why we need intercontinental autonomous ships. Of course, there are many advantages of autonomous ships, like improved working conditions and lower damage-related cost and reduced crew cost and slow steaming, lower structural cost, and it allows some new ship design, and we can have better environmental performance with autonomous ships. And in addition, as you know, many shipping companies worry about the shortage of seafarers, especially for intercontinental navigation. So for instance, according to the Seafarers Workforce Report, you can see a shortfall of 26,000 officers is expected by 2026. And some people say that it can be worse, especially because of the pandemic. So the autonomous ship can be a good solution for this shortage of onboard crew members, in addition to having all these advantages. But, there are many challenges for intercontinental autonomous ship operations. One of the most critical challenges is the long distance, because we need to remotely monitor or operate autonomous ships in all over the world like this. And this long distance monitoring and control can cause various problems, and we need to be prepared for them for successful intercontinental autonomous ship operations. And another critical challenge can be the compatibility. Because, when we have a large number of autonomous ships in the ocean, for instance, like this figure here, then I don't think a single company will provide all autonomous systems and remote control centers for every vessel in the world. The latter, we will have multiple suppliers with multiple systems. Then we can have some compatibility issues because we may need to connect an autonomous ship to another remote control center. So for instance, when an autonomous ship approaches to a port, then a pilot may need to take control of the vessel from their own remote control centers. Or if the vessel is in an emergency situation, then the Coast Guard or the VTS may need to monitor or sometimes remotely control the vessel from their own remote control centers. So then we can have some compatibility issues. And this compatibility can cause various problems. So we should also be prepared for them. And of course, there can be many other challenges and problems for these intercontinental autonomous ship operations. But maybe we can focus on those two today because neither of them can be solved by a single company or by a single country. But I think we need some international collaboration to solve these long distance and the compatibility problems. And I hope the two world-leading countries in maritime industries, the Norway and Korea, can collaborate for this problem. And I would like to introduce one possible joint collaboration idea today. As you know, and as presented by the Dr. Lodset today, we have many research and projects for autonomous ship in Norway. And also, as introduced by Dr. Kim, we have the KAS project and many other activities in South Korea for autonomous ships. So in KAS project, the KAS project will build its own remote control centers and the autonomous ship. And in Norway, we will also have the remote control center by Masterly here in Horten. And we already have Jarabirkeland, and we will have the ASCO next year. So the idea is to connect the remote control center in South Korea to the autonomous ship in Norway, and the remote control center in Norway to the autonomous ship in South Korea. Then we can conduct some research and demonstration of long-distance intercontinental remote operation, and also for the compatibility of different operating systems. And based on them, hopefully we can suggest an international standard for the remote control centers. But however, connecting and operating a large ship from the beginning like this can be a little dangerous. So maybe we can have some step-by-step approach. So for instance, we can demonstrate long distance first using simulators from the same system. This idea was actually from Professor Chong-Ju Che at the Korea Institute of Maritime and Fisheries Technology, KIMFT. And the idea is like this, here in USN, we have a simulator from Kongsberg. And in Korea, in KIMFT, they also purchased the very similar simulator last year from the Kongsberg. So maybe we can connect these two simulators first to demonstrate long distance remote operation and monitoring. Then hopefully we can do some research and demonstration of, for instance, about the time delay of this long distance and the required bandwidth for both navigation and the condition monitoring of the vessels and the cybersecurity and so on. And once it is successful, then we can continue to the next step. And the step 2 is to demonstrate the compatibility of different systems. So in addition to these two simulators, we will have remote control centers of Masterly And we also have a remote control center of NTNU Shore Control Lab. And as introduced by Dr. Kim, the KAS project will have its own remote control centers. So we can connect all these different shore control centers, and we can conduct some research and demonstration of, for instance, the standard interface between different systems and some necessary data for the standard interface. Of course, also for the both navigation and the condition monitoring of the vessel. And after these two preparation steps, we can finally demonstrate with actual vessels. So we can remotely monitor and control the autonomous ship in South Korea from the remote control centers in Norway, and remotely monitor and control the autonomous ships in Norway from the remote control center in South Korea. Then I hope we can have some research and demonstration of, for instance, some standard interface between autonomous ships and remote control centers, and reliability and redundancy of communication systems on board and also on the remote control centers. And also the handover procedure when the autonomous ship control is handed over from one remote control center to another. And I believe we can find many other research topics on this. And based on all this collaborative research and demonstration between Norway and Korea, I hope we can suggest an international standard for remote control centers. And I believe we can suggest much more successful international standard than a single company or a single country if we do this together. So to summarize, with this joint collaboration, we can conduct many research and demonstrations for this long distance and compatibility issues of remote control and remote operation of autonomous ships, like time delay and bandwidth, reliability and redundancy, and condition monitoring, cybersecurity. And I also believe there will be many non-technical issues like rules and regulations, and drivers and barriers, and human factors, the climate and weather conditions, and so on. And for the compatibility, we can conduct research and demonstration of, for instance, some scenarios when we need this compatibility. Is this for instance, for pilot operation, or is this for an emergency situation? And depending on the scenarios, maybe we need different types and different amount of data and information for the remote control centers. And we can also research on the standard interface and the necessary data and handover procedures and so on. And possibly we can also develop some standard remote operation bridge configuration in collaboration with Open Bridge project, for instance. And of course, we can collaborate with many other ongoing projects, like of course, the KAS project, and also for this SFI Autoship project, and the Valkyries and Javas and so on. So I hope we can do this together. And I would like to know your opinions for this collaboration from the industries and research institutions and universities in Norway and Korea. And also wanted to continue discussion for some project applications if you are interested and if you are positive for this collaboration. Thank you.
Thank you very much, Professor Kim. Well suggested agenda. I think we can get into more in detail when we do the panel discussion. But before we go to that, let's give the floor to Dr. Park Han-sun, the Director of Maritime and Safety Division from Korea Maritime Institute. Are you here with us, Director Park?
Yes.
Yes, thanks.
Yes, now is the discussion time.
Yes.
So first of all, I would like to thank you very much for the all presenter. And so it is the excellent presentation and very interesting. And so I would like to thank you for joining today's the seminar and the Korea-Norway Autonomous Shipping Workshop. And then I would like to very interesting to today's workshops. And so I would like to some question about to the present speakers by speaker. And then I would like to ask for if you have any question about today's presentation. And so some audience, please leave your question in the chat room. Okay.
Oh, Dr. Park, you're muted. Director Park. You are, yes.
Now,
yes.
Did you hear me? Yeah.
Yes, yes.
Okay, now is a time to discussion time. And I thank you very much for all speakers, very excellent to the presentation. And then we also to 5 speakers already presented in this time. However, is a time more than 15 minutes has passed. And anyway, to the joining today's to the audience, thank you very much for joining today's Korea-Norway Autonomous Shipping Workshop. And then if you have any questions about today's presentation on today's topic, and please leave your question on the chat room. And so I would like to some question about the speakers by speaker, and then the speakers have a question have a discussion each other. First of all, I would like to the question about the Dr. Jin Kim, and thank you for your explaining the overall KAS project. At the last MSC meeting, I am also decided to develop a roadmap for the mass core. Also, I think that one of the most necessary things for the introduction and the development of mass is the establishment and operation of the KAS shore test bed and center, which will be completed in 2023 as the IMO expectation. And so compared to the test operation center in Norway, what advantage do you think the establishment of the mass center in Ulsan, Korea has? That is the first question. Also, how do you plan to utilize the ships used for a demonstration after 25 years of the project? Another one, Indonesians, although this project is in its second year until 2025, it would be appreciated if you could tell us if there is anything that you think need to be done in connection with this project in the future. Could you tell us your opinion and idea?
Oh yes, thank you for your good questions in a viewpoint of mass control center. Actually, it's the first time to hear a mass control center in Norway. It looks very similar with ours in the sense of functions. At present, it is not easy to say something to compare both mass control center. So maybe if I wish to have a chance to visit there, if this COVID pandemic would be calmed down. real commercial ship equipped with developed autonomous system will be used in final 2 years of this project for the validation of the systems. As you know, this is a commercial ship, so which is owned by a shipping company. So this ship will be on a voyage all around the world, even after the project is finished. But all sailing information will be collected in the big data server at the mass control center, and it will be utilized for the improvement of autonomous system. And also, as I talked in my presentation, mass R&D teams in Norway, Korea, and any other nations should consider a reliable way to evaluate autonomy levels and make an international standard that is accepted by all nations. As one of the starting point, I was very interested in Professor Hyung-Juk Kim's speech. Norway and Korea operate an autonomous ship in their own side mass control center virtually. And so we can test and verify the protocols for communication and standard data structure for autonomous ships. So I think that's one of the good starting way to make these issues in global. For the real advent of ocean-going commercial autonomous ship, many nations suggest the appropriate procedure to validate and evaluate the autonomy levels. So therefore, we should do effort simultaneously, both development of the technology and also together technical exchange in nations. That's my thought. Thank you.
Thank you to the great question, great answer. Relevant to the show-based test center, I would like to the question related to the Norway test bed. And so, did you hear me, the Onolf? Could you tell us, Onolf?
Yes.
Yes. And so I have been to the Tottenham, and so 3 years ago, maybe I have been to their test bed, visiting to your SINTEP, and so I'd like to listen to since 2019 maybe what is the challenge? What is the change of in comparison with now times in Korea the test bed? Could you give me some advantage or to the challenge about the test bed?
I don't think we have that much in terms of challenge, because with respect to regulations, this is something that applies to the whole coast. There's no special regulations for the test beds. What the test bed supplies is an infrastructure and the cooperation between the parties operating the test bed mostly, and that is a bit different in the different regions of Norway. We have 4 test areas today, but basically the test areas in Norway is a cooperation between the parties using the test area. Regulation-wise, it's you can do tests more or less everywhere as long as you follow the safety guidance.
As my understanding is, to the IMO, adapted to the interim guideline of the sea trial and the appointed to the area. After that resolutions, and then is there any problem? Is there any difficulty to the connection, the show-based test center?
I wouldn't say that. I think it's a bit too early to actually say something about the experiences. I think I would add to the presentation on the possible cooperation on test centers, one very important question I have is, how is the operator going to control the ship? I do not think that this virtual bridge is the correct way. You probably need some other types of displays. And this is something that we haven't really investigated so far. So far, it's a lot of screens with the video and some bridge replication, but I don't really think that is the correct way forward. So there's really a big research question here. What is the type of interface we need for the remote operator?
Okay, thank you very much for your answer. And another one is because of the big research spectrum, to the autonomous ships are developing and using the various key issues such as artificial intelligence, big data, and cybersecurity, and the eco-friendly ships. How about to the in a future? You think in order to achieve the net zero, to the decarbonization net zero, and environmental issue related to the greenhouse gas reduction, maybe I understand to the mass is the best eco-friendly ships in the future. What kind of what type of energy the future autonomous ships is coming? I would like to listen to your personal opinion.
If I knew that, I would probably get rich. I mean, what we are looking at today is batteries, of course, for short distance. And we have some projects looking at hydrogen as a kind of additional fuel, but again, in very small scale. LNG or bio-LNG is also one of the possibilities we are looking into. Hydrogen is a bit tricky due to storage and explosive properties. Ammonia is possibly something we need to look at, but it's quite poisonous. So you could say that if you want to use hydrogen or ammonia, it would make good sense to have an unmanned ship in case it blows up or spills some poisonous gas around. But what I think that the main problem with these alternative fuels is availability and the energy needed to produce, for instance, hydrogen and ammonia. And it's not a special problem for autonomous ships. I think autonomous ships will mainly be a relatively small area, so we probably have enough alternative fuels to serve them. But I think personally I would go for biofuel or something. That's easier.
Thank you very much for your comment and your opinion. That is why I have questions to the Korea project is cost is taking into consideration to the energy saving, the eco-friendly to the technology to apply to in the future. The goal target is mass development. And so I would like the question about to the Hyungju Kim, the University of Southeastern Norway. And so you mentioned according to your presentation is introducing the CPR's workforce report to the published by BINCO. And so as my question is, there are many to the accidents is to the on board working because of the stress, and then to the very the weight, a lot of the stress, and then a lot of weight to because more to the documentary working is increased nowadays, is very difficult to as a CPR on board. As my question is, if you have any recommendation or idea to reduce the mental health and the stress of sailor at times when ships are becoming more and more automated and autonomous ships are introduced, I would like to listen to your opinions related to the mental health, how to decrease the stress on board, maybe it's different to the specialization. And so, however, is your to the PIMCO report is, I would like to the question about that. Could you tell us? Yeah.
Yep. Thank you for the very nice question. And as you said, this mental health and psychology is not my main research area, but I believe that if we apply this autonomous technology, then I believe we can reduce the stress and we can improve the mental health of these operators and officers on board. Because if we have fully autonomous unmanned ships, then it means that those officers and operators, they can work onshore, and it would be much more helpful for their mental health. And even we don't have these fully autonomous and unmanned ships, those autonomous systems can support these officers and navigators to reduce their workload so they can have some more improved working conditions. So I think that is, I can say on these issues. And I could see one question from the chatting window,
Yes, yes.
Yeah, and there is about the European Maritime Simulator Network, EMSN. Yes, I didn't hear about this before, but I think it is a very good idea to using this EMSN because now, yeah, it is connected to Asia Pacific Maritime Simulator Network. So yes, I think that this is very good idea. So maybe we can have some more detailed discussion after the workshop.
Okay, very good question. Maybe I think is from the KRISO is Jin Young Park is question on the chat room. And so maybe is some more detailed discussion after today's the workshop, and then is a direct connect with the Hyung-Joo Kim and Jin Young Park is some more discussion about it. And so the last one is my question about related to the to the RCN. Did you hear me, Alexandra?
Yes, yes,
okay,
I hear
okay.
you.
Thank you very much for your presentation, and maybe it's have an endeavor to the between the Korea and Norway to the international cooperation. Maybe you are the variety of the contents to the cooperation to Korea. You mentioned about to the international cooperations. Even now is a various projects related to Mars are in progress by country. Then I think it is necessary to establish an active partnerships between the Korea and Norway in order for this project to be carried out successfully. And so in order to establish an active cooperation system in the maritime industry and create results, I'd like to ask for the special example or personal opinion on what kind of cooperation Korea and Norway should focus on in the future. Could you tell us to your opinion?
Yeah, thank you very much for the question. So, how to establish an active Korean-Norwegian partnership, right? I'm afraid that you will find my answer very unsurprising. So as I said in my presentation, the main principles of the policy from RCN is that we support and encourage internationalization, but at the same time also we leave it up to the research community to decide where they want to build these partnerships. So our main role would be to provide funding opportunities, but it is up to the research community to decide to use them. So I was very interested to hear there are already ideas floating in this discussion on what you could work on together. So just to say, if it's although you will not find calls at the Research Council saying this is a specific call for cooperation between South Korea and Norway, we do have funding opportunities, and I very much encourage you to use those. So we already mentioned and sent a link in the chat to the INTPART call, which is coming up. There is a Utforsk call as well. So starting by connecting connecting through establishing networks, getting to know your partners, finding out who are the right partners, who are you compatible with, and then applying for projects together. So maybe small projects or network projects in the beginning, and then moving on to bigger projects is the unsurprising answer I can give you. And then also to mention the possibilities for EU funding, and especially as the European Maritime Simulator Network gets mentioned, European cooperation is also relevant here. But I can give you a very general answer. I would also like to give the word to my colleague Kjell Røang, who works at the Transport and Maritime Division at RCN, because I'm speaking from the kind of general international point of view, but Kjell can give you comments that are more specific to the maritime sector. So Kjell, if you can fill out a little bit here.
Tell us? Yeah.
Thank you, Alexandra. Yeah, I fully agree with Alexandra. I think to establish, the main thing here is to try to establish project. We have to walk the walk, so to speak. So to start, you have to then establish the network between the Norwegian researcher and Korean researcher and Norwegian industry partners and Korean industry partners. So what she mentioned, Alexander mentioned here with INPART is a good way, maybe to get a cooperation to research institutes in Korea and Singapore. In Norway. But also I think you could use also we have all these different conferences. We have now the upcoming ICMAS conference next year, and there we can try to have some bilateral meeting during these conferences. Or you could also, one way to doing is to have, we have the INAS, the International Association, what is called for autonomous ships, and we have the Norwegian part of this. Maybe I'm not sure, but probably you have something similar in Korea for with all the Korean partners working with autonomous ships. So maybe it could be a cooperation between the NFAS, it's called in Norway, and the similar counterpart in Norway to establish the connections. And I think this is the thing you have to start with. And I'm also curious to hear, I think Alexander maybe spoke about this money for the corporations, but I'm not sure if this money cooperation is applied. You can apply that also to research within autonomous ships or in Korea, because in Norway it's for all kind of research topics, and not limited in any particular topics. But I'm not sure how this is in Korea. But that maybe someone in Korea could look into that and see if there is also the same possibilities for the manifold cooperation in research regarding autonomous ships. Thank you.
Thank you for the excellent answer. And so, did you have any something tell us to the honor?
Yeah, I saw also the question from Alexandra, and the point I think we should keep in mind is that both Korea and Norway has quite extensive research projects ongoing already. And Alexandra mentioned IAGIS, which is a EU-funded research and innovation action, and a significant part of IAGIS is research where we can cooperate with others because it's open research. It's a lot about standards and say RCC operations and stuff like that. So I think already that we have a lot of projects on either side where we can coordinate activities within existing funding. So I think perhaps the most important is to build a network and look for these synergies. Several of the activities in Norway are working on things that is not directly competitive. It's kind of standards, pre-competitive things, and this is areas where we very much would like to cooperate. We cannot necessarily share our funding, but I think if we can use Korean funding on Korean side and Norwegian funding on Norwegian side, we have a very good opportunity already now start cooperating. And I think the comment with this network building, that is something where we should perhaps look for some additional funding just to get it moving. But also, as Kjell says, even there we have ongoing activities we can leverage. But I don't think funding should be an obstacle, actually, in my head at least.
Okay, thank you.
I'm very sorry to interrupt, but I think due to the time limit, I think I love your discussion and I'm passionate about knowing more, but I think we have to move on.
Okay, thank you. For now is this is close to the first discussion about to the relevant to the speaker, the 5 presentation, and because time limit, and then to the I would like to the closing to the first discussion the time, and then could you floor is open to Jason Insubak. You're progressing.
Yes, thank you very much. Because we have a one person actually, he's been waking up since 3 o'clock in the morning from the US, and then he's been patiently waiting for his turn. Our next speaker is Professor Kwang-il Lee from Korea Maritime and Ocean University, and he's going to talk about cooperation for developing international standards for autonomous ships between Norway and Korea. Professor Lee, are you still with us or too tired already?
Yeah, thanks for the introductions. So can I share my presentations?
Sure you can.
Okay. Can you see the presentations?
Yes.
Okay. My name is Kwang-il Lee from Korea Maritime and Ocean University. It's my great honor to present in this seminar. The title of my talk is Cooperation for Developing International Standards for Mass between Norway and Korea. So my talk will be focused on the standardization work in IMO, IEC, and ISO. This standardization work is mainly focused on the current work and possible, collaboration issues together. So as a background, digitalization in the maritime industry, so navigation, smart ship, autonomous ship, shipping 4.0, smart board is introduced, a lot of work. And then MAS will accelerate the digitalization and automation in the maritime industry. But the issue is that, we need to consider the shipping industry in end-to-end. In this regard, we need to thinking about the seamless maritime connectivity shall be provided for the automation introduced by MAS. Also, there's a reason where intelligent maritime ITS becomes more important. What will be necessary to provide a seamless maritime data connectivity? So all service and systems device shall be integrate and interoperate, as other speakers mentioned. What's the challenge for this one? Because the shipping industry is not the single stakeholder. A lot of stakeholders are involved, and then they are using their existing system. So how we can achieve the seamless maritime digital connectivity? So these are the issues: how to harmonize all device systems, services, including data. The international standard will be a solution. So in the CAS project, as introduced by Dr. Jin Kim, the package 7 focused on the international standard. Many international standards involved in the development of MAS, and then not only technology development, we need to consider international standard related with technologies developed. So this, so in this project, we focused on the 3 major international standard organizations. So I will briefly introduce some works related with mass, starting from the IMO. So recently, IMO finalized regulating scoping exercise. They identify the low priority, medium priority, and low priority instruments, which instruments need to be effective to realize and deploy mass in the real environment. Also, they identify some work items to develop mass code. So in the MSC 1.4 sessions, they decided development of goal-based instrument for maritime autonomous surface ship, and then they are expect to develop the roadmap for mass code. So based on this expectation, in our project, we are mass roadmap is under development by Korean experts within this project. So this roadmap development can be jointly work with Norway. This is one of the possibility. Also, IMMSC is discussing about the next edition of the ACTIS. ACTIS or INS will be a major conference for the autonomous navigation in Mars at this moment. So in the ACTIS performance standards, there is one paper is submitted by Swedish Maritime Authority. So they proposal is to enable digital information exchange, including route plan and secure data communication and ship to shore. So this will be maybe utilized in the mass thing. Also, IHO developing S111 based ENC. So this S11 shall be included in the next edition of ACTIS. This also considered in the future MSC meeting. Autonomous shipping is not only related with the MSC. This one is also related with the FAR committee. So FAR committee has established the EGDM, expert group on data modeling. They are going to all data set related with the PAR convention. So they are identify and then assign the unique number for all data element in the uniform way. So these kinds of works might be related with. So I think this work is internationally standardized in ISO, so that the detailed discussion will be explained in later. Another international standard we need to consider is IEC, because IEC TC80 make a standard for maritime navigation and radio communication equipment and system, especially for SOLAS equipment. So some components of IEC TC80, they provide a digital interface. This means data standards between onboard ship equipment and systems. So also working group 6 define the cybersecurity for the navigation system. So they are providing very highly secure standard they are proposing. Also, they are working on the AIS and then VDS and the other GMDS equipment. Also, they are working on the ACTIS and INS and presentation of navigation related information. Also, they are in the working group 17, they are working on the ship-to-shore data interface and communication interface. At this time, I'm going to introduce some works in working group 17. So they are developing a route plan based on S100. So this one is already internationally published as an international standard. This will be utilized to ship information related with vessel voyage, and then it could be utilized for remote control ship to shore. Also, when as route plan is published, they are providing the detailed procedure how it can be used between ship to shore. So mast and shore control center using the this route plan, the shore control center can control the ship with the route plan. So this as photon-based autonomous control test bed might be necessary. So autonomous ship control, how to control autonomous ship from the shore control center can be included in IEC standard if they are using the route plan. Also, another is the SECOM, secure communication for between ship to shore. So this one is providing on how to securely exchange information or how they can manage it, the key for ship and shore communication party. The most interesting thing is how we can maintain the maritime PK for the SECOM. So it needs to be developed for maritime PKI, and then it need to be collaborated with SECOM. So these kinds of things need to be discussed and then need to be developed together. Another international standard from us is ISO. ISO, I'm briefly mentioning about 4 subcommittee. So SS6, navigation and ship operation. SC8, ship design. SC11, intermodal and short sail shipping, and working group 10, and for smart shipping. These 4 subcommittee and working groups are related with smart shipping. As one of the speakers mentioned, ISO 19847, 19848 is to define the ship data server and then how to format the ship operational data. They are standardized the data format. So this can be used for the ship to exchange the operational data information between ship to shore. Also, ISO 23847 is also defined. They are defining general requirement for asynchronous time-sensitive time ship-shore communication. So this is under developing, and they are providing the communication method and then some general guidelines for communication optimizations. So they are providing some general requirement, general guidelines. Another interesting international standards now is ISO 28005 series. So as I mentioned in previously, IMO FAR committee is defining the FAR convention. So this international standard defines standard for electric port clearance. Recently, ISO 2805-1 is revised. Is revising, and then new international standard for 2805 for -3 is proposed as a new work item for data exchange for autonomous operation for ship and port. So this information shall be exchanged to promote interaction between ships and port for the automation. So these international standards are developed by Norway mainly, I think. So these international standards for this international standard development, we need to collaborate together. So for summary, autonomous ship is a game changer in maritime industry. for the new mass, we need to develop international standards, especially in IMO, IEC, ISO. For the IMO, mass code development need to be collaborated together, including roadmap and C-trial guidelines kind of thing. And then equipment and system related. So SOLAS equipment, ACTIS, including ACTIS and INS, and the smart shipping on export EGDM. Those kind of things need to collaborate, but not limited. I only mentioning some issues. I see ship navigation and system standard development for mass. So I think autonomous ship may introduce a new equipment and system. So this navigation related system shall be standardized in IEC. So in that case, we need to collaborate together. Also, shore-based control system with the route plan and the navigation data shall be standardized. And then the security for ship-to-shore control might be considered in IEC, and then need to be collaborated together. For ISO, ship-to-shore port interface and the automation in port in ISO 2805 series need to be considered and then need to be collaborated together. Standard operation data interface between ship-to-shore becomes more important and then need to be standardized in ISO. As I mentioned, my conclusions, collaboration on international standard between Korea and Norway is very important, and then we have a long time history between for the collaboration between Korea and Norway on international standards. And then to establish Korea and Norway standard collaboration framework, so we need to share and communicate with mutual interest, and then joint research on standard development in the mass projects, and then joint proposal and works on the international standard development. Also, many speakers are mentioning about the importance of the testbed. So we also need to have an internal testbed project with new standards, also important. So develop new service with mass, and then develop an international standard, and test and verification for new standard need to be beneficial for Norway and Korea. I only mentioning about some activities related with Korea and Norway, but we can extend those international standards work in other international standard, organization, also other items. Thanks so much. That's it. This is my presentation.
Thank you very much, Professor. Without further ado, let's go right to the discussion session. Director Park, are you there? Can you carry on the development of the international standards? The floor is yours. Professor Lee, can you turn down the share screen?
Sorry. Okay.
Yes, thank you.
Sorry about that.
No worries. Director Park, there's got to be a discussion on the development of international standards. Oh, I guess there's just one panel discussion. Then why don't we move to our last session for closing remarks?
Did you hear me?
Yes. Yes.
Yeah. I'm sorry. I ran out of times to the just only presentation one, and so the less than 5 minutes is have a discussion now.
Sure.
Yeah. And so almost is a closing time is, and so just only to the just one question about to the presentation of standardization of IMO and ISO and IC. You know, to the Korea and Norway has continued to cooperate in technology development and standardization. In particular, is honor also very good contribution to make the ISO standard relevant to the mass definition or relevant to the variety of the definition of guideline to make the ISO guideline. And so the Korea was committee or other to the ISO expertise attended to make the ISO standard. And so I would like to have our questions to the Professor Lee is, I think that the joint cooperations of IMO and ISO and IC is of utmost importance in relation to the standardizations of autonomous ships. I would like to the question about to the if you could suggest concrete action plan, future plan or idea to promote international standards cooperations for both Korea and Norway in the future in terms of to the IMO, ISO, and IEC cooperation. Could you tell us to your idea and personal wisdom? Thank you.
Thanks for the questions. Okay, I think many speakers are mentioning about collaboration issues between Norway and Korea. International standard is related with the technology development. So we need to consider technology development and international standard together. In this perspective, I need to mention some suggestion related with collaboration between Korea and Norway in international standard perspective. Personally, I have worked with several international standards with honor for 15 years, and then we had, I think we have a very productive collaboration in the development of international standards. However, we need more extensive and intensive collaboration in the international standard development for the mass. For this, I would like to make some suggestion. As an initial step, it is required to promote the exchange of information, experience, and experience sharing with the regular programs. Even though we have some seminar and workshop, we don't know yet. We don't know exactly in detail and what kinds of technology they are developing and what kinds of international standards might be necessary. So based on the regular programs, we can promote which technology or which core technology and which standard they are developing in each country. Based on that, we need to identify which standards need to be applied and to be developed together to promote the mutual interest. Also, we might have a joint meeting, online or offline meeting can be held to prepare and to work the agenda or issues together for international meeting. So this kind of pre-meeting will be beneficial to collaborate together in the international standard organization. Already, as we already discussed in the previous speakers, we need to establish joint research project for mass Norway and Korea, especially for international standard focused. So when each country already established their own many mass related projects, but after the project starts, it is not easy to participate the development of the international standard. So from the beginning, we need to participate the collaboration issues, and then how we can collaborate in the international standard. Then needs to be considered in the starting point. Also, verification and validation of international standard is also important issue. As many speakers also mentioned, it is required to have a joint test bed and perform joint tests for international standards using digital infrastructure, which is developed in each country. Based on the experience, we need to establish the verification process for the type of those kind of things need to be collaborate together in terms of international standard. That's it.
Yeah. Thank you very much for your excellent answer about to my question. And so, you know, to the already many times to the have passed, maybe it's time to close to the discussion. And so if you have any question about the chatting room, and so if possible to the relevant to the organizer could personally his answer is very helpful for the question about. I'm very sorry to the whole of the question on chatting room is very sorry. And so the organizer is have an answer, personal contact, and then discussion more is continue. Thank you very much is closing to the time, discussion time. Thank you very much.
Thank you very much, Director Park. Not last but not least, I would like to introduce our last but not least speaker, Sven Grandum, the Director of the Innovation Norway in Seoul, for the closing remarks. Sven?
Thank you, Jason, and thank you everyone for excellent contributions to today's webinar. I think the discussions that has been taken place during the last 2 hours just shows the importance of collaboration, both bilaterally but also multilaterally. I think it also shows that it has been a while since we did this last time. So I think this just triggers our motivations to follow up. I think we have got a lot of good recommendations for how we can develop mutual and good partnership between Korea and Norway. I think Professor Lee's final remarks actually is a good summary of things that we can absolutely work closer on, and not surprisingly, the standardization and regulation issues is a key here. Test beds as well. We have learned a lot about funding opportunities that are available, and I would like to also thank our partners in Team Norway, Research Council of Norway, for excellent input to that. So there is funding available, so we just need to create the good projects and to formulate partnership based on that. So I think we have a lot of things to bring with us, and from our side, we will do our utmost to support a partnership dialogue and further cooperation. Let us know if you have any questions or things that we can contribute with. And I would also like, being a part of Innovation Norway and Team Norway, to thank also our Korean partners, particularly our co-organizers for this event, but also the others, KRISO and the others, for excellent collaboration to put this together. I think we will speak again to discuss further how we can develop the collaboration. So finally, thank the key persons behind this webinar for hard work and good efforts to bring us together. So thank you all for excellent presentations, contributions to this webinar today. Thank you.
Thank you, Svein. Dear participants and speakers, this is all we have prepared for today. And huge thanks to the people who have prepared in the behind the scene. One from KRISO, Grace Lee, thanks very much. And Tuseok Kim from Innovation Norway here in Korea. Thanks once again, and we wish you all the best and hope to see you soon again in person. Thanks very much. Bye.
Thank you. Bye. Bye-bye.
바이바이.
Bye-bye.
상무관님 수고 많으셨습니다.
수고하셨습니다. 자료 사진 보내드렸습니다.
네, 받았습니다. 그 레코딩 자료 부탁 주시면 제가 유튜브 만들겠습니다.
내일
교수님 수고
보내드릴게요.
많으셨어요. 잠도 못 자시고 좋으시고 이거 미국에서.
별말씀 수고 많으셨습니다. 예.
수고하셨습니다.
고생 많으셨습니다. 박한혜 시장님 모두 수고 많으셨습니다.
감사합니다.
우리 김소영 박사님한테 질문을 못해서 시간 관계상 죄송합니다.
고생하셨습니다. 박한선 실장님.
예, 고생하셨습니다. 예.
네. 예.
네, 건강하십시오. 들어가겠습니다.
네.
수고들 많으셨습니다.
수고하셨습니다. 굿바이. 바이바이.